All right, so in the attempt to kind of give a brief overview of kind of the history of Ecopia and its current state today and all the stages in between, I think I'd start with the idea with Ecopia was that the web switch market defined a different way to think about building web-based infrastructure. And in the course of thinking about storage, we wondered, is there a way that you take some of the approaches that were used for web switching and the emergence of more advanced forms called application delivery controllers, could that same technology be applied in some ways to data? And so the emergence of that was a product we called the ARX, which was an adaptive switching element that understood how to proxy not the web HTTP, but proxy the CIFS and NFS protocols of data. And once we did that, we were able to remove the dependence on a physical storage device from the user's access to that device. So very simply, a virtualization layer was created that allowed you to create a virtual version of the storage presentation that users and applications could use. Meanwhile, the device itself, this ARX, was responsible to manage the location of those individual items that made it up. So fairly similar at one level to what a web switch had to do. Data is quite different from web traffic. There's integrity, there's two-phase commits, there's database operations that are quite concerning that have to go on. But if you ignore those kind of characteristics, pretty similar in that way. And so things like load balancing a farm of web servers and load balancing a farm of file servers were things that you could do with an ARX that were used. What we found in the market was the most common applications of this technology were first to move between one vendor and another. So if you in fact have a large NAS infrastructure and you're with a particular vendor, movement to another vendor was incredibly painful. And obviously the vendors were not particularly interested in making it easier to move off their base. So this ARX filled that vacuum to say, if you really have a need to move from this vendor to another vendor, here's a way to virtualize that infrastructure and facilitate that movement without disruption to the users that went on. A follow-on to that was to kind of make that migration a permanent part of the namespace, where movement for individual files based on tiering was really another form of migration, except you were permanently responsible and it might be bidirectional and so forth. So kind of taking that, I need to be in band for the migration, I stay in band to handle the ongoing placement decisions that go on between files. And that really helped drive, I think, much of the industry's understanding of the true benefits of tiering. I was talking to some previous folks about this, that 4 years ago, tiering was still not well accepted as a technology by the broad market, but selectively, and we were certainly talking about it. I think now it's very clear to everyone, and everyone is spouting that you need to do something that amounts to tiering, which involves moving data between different types of storage technology to optimize its performance, its cost, and its long-term storage needs. So that's where we are today. Where I think this goes is that that's established us as, I think, the primary vehicle if you want an enterprise or large service provider to be able to move data between different heterogeneous storage elements at the file layer. We're really the only solution in town. There are alternatives to managing storage that obviously don't involve that, but if you need to move data between, you want to have the freedom to choose different vendors' technology and to bring it in and try it out, as I described earlier, in various limited ways. This is really the only game in town, and our business has been built from that. Where I think the business opportunity is going forward that can be much bigger is to move to where data starts being treated more like a traffic, more like what we treat web and applications. So the web switch started as a simple load balancer that said, I will find a way to scale this up, and it's now become a much more application-fluent element that knows how to do things to the data flows that affect the application's delivery to the end user. So you can differentiate the service, you can isolate security concerns, you can correct application mistakes. I was talking to some previous people about the idea of just a data device that could store the references made to storage for a long period of time, such that you could go back in time and determine why at 4 o'clock yesterday was storage misbehaving. So there's almost a forensics piece of this that would go on that would just, in our mind, be logical outcomes of accepting that this flow of information that the storage vendor thinks of centered around the need for stewardship of the file or the block that's there, this other element would think about how do we better match the application and business needs for that flow and do things to it that might involve sending its request to a different location like we do today. It might involve recording what came through. It might involve stopping a particular operation from going through. So I think those will all become a form of data traffic management. And just like we found with web and application and the emergence of application delivery networking, that went from being a tens of $100 million to being well over billions of dollars of market. And F5 was able to establish itself in a leader there. This is definitely earlier than that obvious one that's going on there, but I think it's another opportunity that will be similar in size, and we still believe that.